Alright, well, this is how it went. That's my simple setup for soldering, making sure it's square, and I'm going to soft solder it, but I'm going to use a high melting point soft solder. I'm using a pylon of solder along there and heat from this side. And that's it, solders run nicely out the back, and it's a nice fillet along the front. That'll do nicely, and now I'll do the other side the same. As you can see, I've milled slots so that they're accurately placed. Not quite so happy with that one. It hasn't flowed through to the inside. Okay, not so neat, but it's now flowed through, but I've got more solder than I want, so I'll scrape that back. Well, I've no doubt the more observant ones of you will have been screaming, "You've got it the wrong way round." Yes, well, we all make mistakes. I've gone back to the other flux. Hasn't quite gone right through. much better. You can see the fillet there. I've got a weight on the top to make sure it was seated. Yep. That one's perfect. Seal both sides with a nice little fillet. The next thing I have to do is solder these little tiny plates onto the back of the buffer beam. And at the moment I've got one balanced there somewhat precariously. I don't know whether it's going to work or not. And I'm using the lower melting point solder in the hope that I won't melt the actual joint on the other side. So we'll see how it goes. Right, reset. There's enough there to... There may not be enough heat in this. No, not enough heat. Okay, the bigger torch, but there's a danger that pressure from it will move the plate. So let's just see. Alright. Trying to see if it's gone right through, but I can't tell. I'll try and run some down the back. I think it does. Okay, let that cool off. Well, don't know whether that shows, but it's not straight. When it moved, it's knocked it out of square, unfortunately. So I don't like that. It'll have to come off and I'll try again. Well, okay, they're done. The first one went on much more easily because it was tinned. So this one, you can see I've balanced it with a bit of cardboard there because this thing isn't dead flat. But you can see now underneath here the solder is run down, and so I've got a thickish lump at the bottom, which is understandable, but that'll soon scrape off. Just a little on the warm side. There it is. It's quite strong. So that's the basic chassis now finished. So it's what stage to do next. I suppose normally if I were building the engine, the next stage would be the axle boxes in here, the wheels and the axles and so on, to get it onto a running platform. Anyway, that's not too bad, quite pleased with that. What makes a good model is the definition of all the detail. And this is quite small. And here, for instance, I've got an ordinary household pin. And that's the size of a rivet for this particular model. And that's very small. And when I think about the other things I'd have to make for this model, things like the clack valve which goes on the side of the boiler, it's actually a tap, it's got a handle on it. And I don't think I could make one small enough that would look realistic to fit on this particular model. So, having spent all that time making all this, you guessed it, I'm not going to make that one. I've changed my mind. So, the alternative then is to make a bigger model. And that means the side frames will have to be in two parts because of the amount of space I've got on the milling machine. In particular the X travel. Now if I go out to a quarter, that's not too bad, but it would be better if it were bigger still, so I think I'll go it up to a third. Now a third is quite a reasonable size. It will end up about 600 millimeters, that's a couple of feet long, which is quite a big model, so I should be able to get some quite decent detail into it. It would be possible to make it an actual working model in this size, but I don't have a track, and the spacing on the wheels, I've no idea what it's going to be, but I'm sure it won't match anybody's track. It's just going to be a working model. But there's no reason why it couldn't work in a stationary position. I could have it on a rolling road or something like that. Even down to the slide valve. Thinking about the actual slide valve on the cylinder, on the chest. On the one I made, I think it was about 6 millimeters. It may have been a quarter of an inch if I was working in imperial on that, and 1/3 of that is 2 millimeters, so it's quite feasible that I could make the inlet port 2 millimeters wide and it would actually work. So it's a consideration I shall think about when I carry on making the model. And I've made a start. Here are the two pieces. Which fit together like so. I'm using 3mm brass. I've got a good supply. It's about 30 years old, I think, from the days of clockmaking, and in that time it's become much harder, which is just what I want. This time I've changed cutters. I've got a 3mm slot drill this time, so it's only got 2 flutes. And I've upped the revs to 4,000, and now there's no trace of a wobble in the corners because I've got a proper collet holder for it. So all I've got to do now is make the other side and the ends, the buffer beams, and put them together, and that's it. Thanks for watching.